Welcome to Computer Networking and the Internet class. Today we will discuss blockchain. I am your host, Dr. Isara Anantawarasin. First, let us talk about what a blockchain is, and then we are going to discuss cryptocurrency, and then we're going to move on how to see how it works. All right. So before we talk about cryptocurrency, let's talk about currency first. Currency, which is money or something that is used as a medium of exchange. Before money, we use barter trade, right? Barter trade is the practice where you have a product and you want to exchange with another product. And as you can imagine, that is actually very difficult because, for example, I have a banana and you have pork, okay? And how can we trade 1 kilo of pork and I don't know, 1 kilo of bananas? It might not be fair, all right? And if you can get a fair trade, the next problem you're going to have is that you need to find the guy that wants your banana. Otherwise, you don't get any product you want or any services that you like. So that's where money comes in. And money, since the ancient times, they have been controlled solely by the government. All right. Well, today is too. You can't just print your own money. You can't mint your own coins. Everything has to be controlled by central banks. And their values can be influenced by economic situations or sometimes government interventions when they think they need to intervene. And it actually works. Okay, it works until today. We used to use money. Governments to control the flow of our monies or currency. All right, and the guys that keep track of transactions, okay, usually are banks or financial institutions, and they're keeping this in what we call a ledger, or you can think of it as an accounting book. All right, Alice transfer money to Bob, Bob transfer to Charles, Charles transfer to Trudy, Trudy back to Alice, and so on. And these transactions are kept by usually banks. Okay, and the banks are controlled by the federal banks, or in Thailand, it is Bank of Thailand. And if you use some other kind of transaction, digital transactions, for instance, Apple Pay, Samsung Pay, Line Coins, all these companies must register as financial institutions. All right, and they too are controlled by Bank of Thailand. The problem is, can we really trust them? Are we sure that the government does not interfere too much? Okay, how can you be sure that the bank doesn't cheat on you? How can you be sure that today you have 10,000 baht, tomorrow you're gonna have like 10,001 and so on? And can you be sure that the banks actually compute your interest correctly? Is somebody stole from you or not? You don't know. So let's come to the last question: do we trust them? In other words, how do we verify and keep track of our transactions? Okay, their legitimacy, their integrity, the data hasn't been changed, and transaction hasn't been adjusted or hasn't been added or changed later. How can you be sure that all data are secure, nobody hacked into the core banking system and store any of our data? And can we be sure that all transactions are correct and can be trusted? How can we check, how can we verify these transactions? To address those issues, all right, a new bookkeeping method was proposed, and this is what we call blockchain. This technique was first proposed to be used in what we call cryptocurrency, Bitcoin, in 2008 by Satoshi Nakamoto. We do not know who this guy is, okay, or was. Maybe it's a guy or a girl. Maybe it's a group of people. We do not know. All we know is Satoshi Nakamoto is a very quiet person, and he kept his secret very well. A blockchain is a ledger of records, or well, we can think of it as an accounting book. Okay, it records the transactions. A owns 200 baht and A transferred to B, and now B received 200, and then he used to have 500, now he has 700, something like this. All right, it's a ledger of record of transactions. And well, to be precise, it could store a little bit more than just transactions. It could store any kind of data. All right, but it is arranged in block, and each block store a batch of data. Okay, and all blocks are linked together using a cryptographic method that is a hashed function. Okay, each block uses a hash function to refer and identify previous block, and this form an unbreakable chain of block. Let me explain how it works real quick. All right, we have set of data transactions. A transfer to B, B transfer to C, A transfer to C, and so on. Go on. All right, and we keep this in a page of accounting book. So we keep it into a page. Okay, draw it like this. So now let's just say after like 20, 30 transactions, we want to save this page. What we're gonna do is that we are gonna apply the hash function, okay, into over the data of this page. And a hash function is a one-way function that can map an information, okay, any kind of information to what we call a hashed value. So basically you have the input of the hash function and you have the output of hash function, which is what we call message digest. Okay, we call it hash value. Or a digest. All right. The hash function always produce hash values of this of the same length. No, regardless, no matter how large this message is. So, in case of Bitcoin blockchain, the length of this hash value is 256 bit long. Okay. Now we call it a digest. All right. We can just call it hash value or digest. Doesn't matter. Now we have this, and because the hash function has this property where when you change something in the input, no matter how small the change is, it could be 1 bit, 10 bits, it doesn't matter, just no matter how small. Imagine that, for example, you have a hash value of xxxx right here. You change a small value here, all right, 1 bit from 1 to 0. This it could result in a hash value that is totally different from the previous one. It could be y. All right. So you can't change it. If you change anything right here, no matter how small the change is, this hash value will completely change. All right. So now you can use this hash value to verify the integrity of the information on the left hand side, that to verify whether somebody had changed the original info or not. All right. Now, next step. Then you keep track of the records that go on into your account. All right. So you have another page of your accounting book. 1, 2, 1, 2, 3, 4, 5, and then what you want to what you want to do is that you want to save this page as well. So you're gonna apply the same thing. This page, apply your hash function on that, and you're gonna have this hash value. All right, and let's just call this v1 for hash value from page 1, and it's called page 1, okay, or page 2 right here, and this is the value of this is the hash value v2, because it comes from the accounting page 2. All right, but what blockchain does is a little bit more sophisticated than that. What it does is that it takes in v1 and puts into page 2 as well. So it's basically take all transactions that occur in page 2 attach V1 at the back, all right, and then apply hash function together. So the result V2 right here is actually the result of applying hash function over these transactions and V1. And imagine that I have this, I don't know, A, right here, okay? When you have next page, page 3, okay? Of course, you're going to have transaction here as well. In here, what you're going to do, you're going to do the same thing. You are going to apply, you're going to add V2 at the back of this page, together with the records of transaction right here, and V2, you apply hash function over it. Okay, bam, like so. And let's just say you got BBB. All right. And this is the final hash value, okay, a final digest that you apply h over the data on the page 3 along with V2. But this is the most awesome thing about blockchain, because this is not just the result of this block, it is a collective result of the entire chain. If you change something right here, okay, the, you are going to have the different hash value from xxx to yyyy, and because you have different hash value here, you're gonna have, instead of this yyyy, which is the result of xx, you're gonna have another hash value that is yyyy right here. And because of that, this value is gonna change. Because of that, this value is gonna change. So if you change anything in any block in the chain, okay, the hash value of the blocks after the change will be different than the original hash values. With this kind of chain of hash values, you can't tamper with any blocks on the chain. The chain's integrity is always intact. So everything in the chain is intact. Okay, you can be sure of the data integrity, because if you change anything in any block, all the blocks below that gonna have different hash values. But what if, you know what, I have time, I have computing power, I want to change everything. I can just recompute all hash values of all blocks. It's not too much for me. Well, actually, you can do that if you own the chain. If you are the one that control the entire the entire chain. Okay, if you are the only one that can compute or recompute the chain. And Satoshi Nakamoto proposed something that is very important concept. Okay, we call it the distributed ledger. So it is distributed in the sense that anyone can make a copy of the chain. So once you distribute the chain, once you open up your data, it means that everybody can cross-check the data integrity. Okay, because everything is public, you can always check that your data is the same as other guy's data. The other guy can also check whether my data or your data is the same as theirs. This could be a good thing or a bad thing. The first thing is, okay, the good thing is the data will never be destroyed, because if my computer is crashed, okay, my hard drive is destroyed, I can always copy the chain from other guys. So basically, I have a free copy, and nobody can tamper with the records. If I change something, or if anyone change something, the other guys can always point out that, dude, I mean, your data is strange. Okay, your record doesn't conform with mine. But that also means that everybody can see all transactions. It means that you will not have a privacy. Everyone will know how much money you have and how much money you transfer to anyone. Blockchains and cryptocurrencies use private key and public key pair to address the privacy problems. And we will see later in the next few slides how they work. But right now, let's just discuss a little bit more on cryptocurrency. Cryptocurrency is a digital currency that uses the distributed ledger technology to ensure the data integrity. And the most popular cryptocurrency right now is Bitcoin. It is also the first cryptocurrency ever proposed. The core technology behind Bitcoin is blockchain. And I would like to emphasize here that Bitcoin uses blockchain to operate. When you talk about blockchain, you have to understand that there are thousands and thousands of coins or cryptocurrencies. Bitcoin is one of them. That is, cryptocurrencies are records of transactions in different chain. One chain, we call this Bitcoin, and the unit of transactions in the Bitcoin chain, we're going to call it Bitcoin. The unit that is transferred or being transacted in this particular chain is called Ethereum, or we can call it Dash, you can call it SLP, you can call it BNB, you can call it USDT, you can call it anything. All right. So basically, cryptocurrencies are records of transactions, and different cryptocurrencies are record of transactions of the transaction in different units. Bitcoin is simply one of these units, one of these cryptocurrencies. And you can use the same technology, blockchain technology, to store any kind of data. It could be medical records, it could be student records or the exam results, or it could be, well, contracts. It could be used to keep the to verify the ownership of any assets, digital asset or the actual asset. It could be used to keep track of birth certificates or citizen data. All right, anything. Today you have thousands and thousands of coins. You can even create your own coin following a YouTube video in a few hours. But Bitcoin is still the most important one. It is also the first one. In 2010, Bitcoin was used to buy pizzas. At the time, all right, Laszlo Hanyes bought 2 pizzas for 10,000 BTC. That is around $25, which is the price of 2 pizzas. And I do hope that the owner of the restaurant still own that transaction, still own that Bitcoin, because that it is proven to be the most expensive pizzas ever made. 10,000 BTC, okay, at the time of recording, it was around almost $500 million. I have to admit that a few weeks ago, it went up to almost 700 million, and it was 650 in April. So the fluctuation, as I told you, is crazy. In any case, Mr. Satoshi Nakamoto owns around 1 million of them, and you do the math. So how does blockchain works? Let us start with hash function. A hash function is the mathematical function that is many to one. That means different inputs could be mapped into the same output. But what we are looking for is a hash function that minimizes this, what we call a collision, the situation where you have 2 inputs that map to the same output. And more than that, hash function maps the data of different sizes into the same fixed size value. What it means is, no matter how large the inputs are, the results of this input will have the same size or the same length, and usually we measure such length in bits. Also, because hash function is many to one, it means that you have different inputs that could map to the same output. It is difficult, actually impossible, to work your way back. If you know the output, you can't just compute your way back to the input. And the hash function that we're looking for is a function such that it is difficult, extremely difficult, to find two inputs that map to the same output. The result of a hash function is usually called hash value or digest, or sometimes we call it hash code. This is an example of such hash function. You have the input I love you right here. Okay, applying hash function over this input, you have this digest, right? And in the second row here, you have I love you with a full stop. You apply the same function, you have this digest. As you can see here, with such small difference, just one full stop here could lead to totally different digest, and this is what we're looking for in the hash function, because you can just use this hash function to verify that the message has been tampered with or not. Now let's see how Bitcoin employs hash function to generate a block. First, we have transactions A, B, C, and D. Okay, each transaction, we apply a hash function over it. H of A, H of B, H of C, H of D. They denote the hash values that of A, B, C, and D, respectively. And the hash function that we use is SHA-256, which is a hash function that produces the digest with 256 bit long. When we finish hashing, okay, a pair like this, we're going to put this pair together and hash again. We're going to put this pair together and hash again, and we're going to push these pair together and hash again. This tree of hash values is called macro tree. All right, imagine that you have more than 4 transactions. You're going to have maybe like 50, 40, 100 transactions, I don't know. And then you're going to create quite a large tree. But altogether, you are going to have a hash value of all of them. Okay, and in each of these transactions, of course, you're going to have a hash value as well. So you know the integrity of each transaction, and you know the integrity of all transactions in the entire block. And not just that, we are going to add, okay, the hash value of the previous block into the current block as well. In this example, we are working on block 13. All right, so the previous block is block 12. We're going to put the hash value of block 12 here in front of the hash value of all transactions here, along with timestamp, the timestamp when we created the block, and announce. And we're going to discuss about announce later. Right now, it is just a value. Finally, we are going to apply a hash function over all this information. The previous block's hash value, the hash value of the current transactions, timestamp, and nouns. And finally, we're going to have the final hash value of block 13. As you may recall, the distributed ledger technology allows many computers, many servers, or in this in cryptocurrency terminology, we call it a node. All nodes can have a copy of the chain. Therefore, all nodes can compute a new block on their own. Now, when you have transactions, all right, when you have transactions, new transaction coming up, you want to be you want to build a new you want to build a new block. So when the new transactions come in and you want to create a new block, all nodes can do at the same time. Now, when one of these nodes finishes computation, it is going to broadcast the result of computation to all other nodes. all right, and other nodes can verify the results of a new block. When other nodes want to verify a new block, they have to compute the transaction, the hash values of each transaction, and the hash value of each step of macro tree, and in the end, the hash value of the block. All right, and then compare this hash value that they got with the hash value from the node that computed first. If the result checked out, if they are the same, it means that everything is correct, okay? And it can accept the result. If 50% of all nodes in the network accept the result, that block will be added into the chain, and the one that submitted the block, all right, I will call it the winning node, will get some reward back from network. And the reward usually is the cryptocurrency that that network is operating on. For example, if you win Bitcoin computation, you will get Bitcoin as your computational fee. So everybody can compute hash values. Remember that everyone on the network can have a copy of the blockchain. All right, so I can compute the new block, you can compute the new block, and in case of Bitcoin, and I believe or most of the cryptocurrencies, the one that compute first is the one that get all the computational fee. And hashed function is actually very easy, very fast to compute. So determining who is going, who wins or who computed first, who finishes first, will be very difficult, especially when Bitcoin nodes spread all over the globe. And Satoshi Nakamoto has thought about that. Okay, so he invented a process called mining. All right, it worked like this. So everybody has the chain. Okay, everybody has new transactions. They are going to compete in a competition. All right, in kind of deliberately hard problem to and then this problem is added into the hatching process, and because the problem is difficult uh, to compute, all right, the node's gonna have to spend some time to think about the result, to obtain the result, and that process. Okay, that process kind of slow down the computational time to determine the winning node easier. Okay, and this process is called mining. And the reason why it is called mining is because the winning node can add the transaction fee or processing fee directly into the block out of nowhere. So basically, the winning node just generate its own money, and that money, well, because it dig up from the ground, you just found it out of thin air. That's why they call mining. The network allows that to happen, and all other nodes must agree that okay, the winning node process these transactions and also automatically add its own processing fee into the block as well. So hash function is actually an easy mathematical process. How to make it difficult, how to make it competitive, so to say. Well, the process is that you can't just find a hashed value. You need to find hashed value with specific properties. Let's have a look. This is, in a sense, how Bitcoin actually works. Okay, we call this process proof of work. We'll discuss in detail about proof of work in the next slide, but right now, let's see how it works. Given a string, hello world, this is our, let's say this is our input, okay? Normally, when you just apply hash function over the over this line, this sentence, you will get the result pretty much right away. This is a straightforward process. All right. Remember, we are using SHA-256. These hash algorithms designed to work super fast. But the question is a little bit more than that. We don't just want any hash value or just simply apply hash function over this sentence. We want a hash value that begins with 000. Now, you can't just start by 000 like this and work your way back to the input, because as we mentioned earlier, hash function is one-way function. You can't make your way back from the output to the input. So you just have to guess the input. You just have to guess and guess and guess and guess and try all the inputs such that it produces hash value with these properties. In this case, you finally produce 000, and one more here. And how do we find this? How do we adjust our input such that we have the desired output? We adjust the nouns. All right. Remember that when we discussed the this block creation right here, we have the hash value of the previous block 12. We have the hash values of our macro tree. All right. We have the timestamp. All these values are fixed. You can't change it. What you can change to get the desired hash value or your output of block 13 is just these small parameters that you can change to any value you like, the nouns. All right. So it means that you need to adjust this little value right here of 0, 1, 2, 3, and in the end you have 4,250. That gets you 0, 0, 0, 0, and that's satisfy this condition. And here is this: there is no easy way. There is no straightforward way. At least we don't know it yet. The way to compute this hashed value, okay, with desired property from just any input. We don't know that. We just have to try and try and try and try until we get this. And this process is called proof of work. It is to prove that you have done some work. You don't just submit as soon as possible, or you don't just submit with no effort. You need to prove that you have spent some expenses. You need to spend some effort or work into processing this value. Proof of work, or POW, is the process of verifying that you have done some hard work. In Bitcoin, when miner find a new hash value of a new block, every other nodes must verify that the hash value of the block is correct and it satisfies the condition that the network given, which is how many zeros in the beginning of the hash value. The process is simple. You just have to guess the nouns. All right. Individual block that will be added into a Bitcoin chain will have to pass the hash condition. Okay, the hashing parameters that we mentioned earlier. So basically, the network gonna say this next block you're gonna find hash value that begins with 10 zeros, 5 zeros, 15 zeros. The reason why we do this is that we want to limit the time to generate a new block to around 10 minutes. Satoshi Nakamoto foreseen that at his time, all right, the machine in his time can process fast, but the machine in the future is going to be faster and faster and faster and faster. So he just add this condition in the way that if the current block process in say 8 minutes, it means that the machine is fast. We have a lot of processing power in the network. You're gonna add more zeros into the condition. So for instance, instead of 10 digits 0, add 11 digits, 12 digits, and so on. until it is so hard that even no matter how fast your machine is, the machine gonna take some time to come up with the result, and that some time is 10 minutes. So every Bitcoin block will be produced in about 10 minutes, plus minus a little bit. If it is produced, if it is if it is processed, say in 11 minutes, then the network gonna reduce the digit such that it kind of ease the problem a little bit. Or if the network is processing the block too fast, the network is going to adjust difficulties a little bit more. And this prevents any individual or any node that has a lot of processing power to dominate the entire chain. What does it mean? It means that if anyone has the high processing power, they are going to keep winning and winning and winning all the time, and it takes everything from the network. And this anyone could be a huge company, big investor, or even a government. Proof of work is designed to prevent such problem. It also makes it very difficult for anyone to deploy large number of nodes to obtain majority of the network. If you obtain majority of your of the network, all right, or majority of the nodes in the network, you can alter any content in the network in any way you like, because no one could oppose you. You will always win. However, proof of work comes with a price, a high price. Most of processing power is wasted for free because only one node can win, and winner takes all. So the work that is done by all other nodes would be spent for free. And this disadvantage of this proof of work has been identified long time ago. We know for a long time that if you keep doing this, you're going to burn a lot of energy for free. One of the solutions, or one of the alternative methods to over proof of work is the proof of stake. In proof of stake, the winner, I mean the guy that has to that has the right to compute the current block, all right, or the newest block, is determined by the stake that he has in the network. And the stake is computed by the wealth and the age. For example, how much coin you have, the coins you have in the network, how much you invested in the network, and how long have you stayed with the network, how long have you invested in the network. And if you have wealth, if you have the age, means that you have contributed to the network, and therefore you should be selected to be the first one. But it is a little bit more than that. To select the guy to compute the next block and therefore get the fee, all nodes can propose themselves. Okay, so I want to compute, I want to compute, and the network is going to select the nodes randomly, but it is not a fair random. It is going to be a weight random, and the weight is computed by the stake. If you have more stake, you invested more in the network, you're going to have more chance to be selected to be the guy that computes the next block and therefore get the fee. And the examples of the network, or the chain that use proof of stake is BNB from Binance, or Dash, or Ethereum 2.0. Ethereum, the current version of Ethereum in 2021, still use proof of work to select the node, okay, and therefore get the fee. But as far as I understand, up from 2022, Ethereum 2.0 will be released, and that Ethereum in Ethereum 2.0, you're gonna they will change the process from proof of work to proof of stake. And apart from proof of work and proof of stake, there are many other methods available. For example, proof of space. Instead of proving how much computational effort you just spend, it proves how much space you just use or how much memory you just spent. All right, you have proof of burn, proof of personhood, for instance, and you can have a look at them later. Now you have all the necessary basics. Let's see how Bitcoin works in the real world. This is the screen capture of a website, blockchain.com. All right, blockchain.com keep tracks of all major blockchains. All right, and this is the Bitcoin chain. At the time of the record, this is the highest block. It was mined a minute ago. All right. And as you can see, the price being here. So if you want to invest in cryptocurrencies, please, well, be careful. Anyhow, when we zoom in into this block, all right, you're gonna see that this block, okay, 713627, okay, has been mined on December 11, and the reward of that block is 6.25 BTC, equals to around, well, just a little over 300,000 US dollars. Okay. Now, this is the hash value of this block, and as you can see here, it begins with a lot of zeros. In the example that we had before, we have like 3 or 4 zeros. This is like much harder. In that block we have 160 transactions, and let's see inside each of these transactions. All right, this is the very top transaction in the block. This is the processing reward. So as I told you, the node that processed this block gonna add the processing fee to himself automatically. In this case, this is the newly generated coin or newly minted coin. All right, and that coin, that value 6.25 will be added into this account out of nowhere. In contrast to normal transaction, this account is transferring some Bitcoin to this account right here. As you can see in this example, okay, the account BC1 had 0.9 BTC. All right, he transferred 0.03177 BTC to this account, and the rest back to his own account. All right, BC1 to BC1. This is to prevent double spending. As you can see here, all transactions are open. So basically everybody can see all transactions. And yes, we are in the block number 700 something thousand, right? We can track all transactions from the very first block, the Genesis block. Everything is open. So the problem that we have here is that where is our privacy? All right. So when the blockchain is distributed, the ledger is distributed. Every node that processes ledger, basically you and me, anyone can see content of this ledger, like we just have that we just did before. You don't have any secrecy, you don't have any privacy anymore. So everybody is gonna know who transfer how much to whom, and can always keep track how much each account has, right? Blockchain, okay, Bitcoin prevent that by hiding the individual behind public keys. Blockchain is going to store only the public key of the spender and the receiver. So it says only that this account number 001 transfer to 002, without saying that this account 001 and 002 belongs to whom. It is the same as when you transfer money using PromptPay in Thailand. PromptPay maps the bank account to a telephone number or a citizen ID, right? Imagine that you have only the telephone number of someone and that someone asks you to transfer, say, 100 baht to that telephone number, you don't actually know that this phone number belongs to whom. The bank knows, not you, not the not the sender. All right, and it works the same way. Uh, in Bitcoin and most cryptocurrencies, you are using public keys to use as the account number. All right. The sender has public key, the receiver has public key. The difference between prompt pay and blockchain is that there is no link between actual entity and the key. So we do not know who owns the key. And how can you know that I gonna transfer 1 Bitcoin to this guy? It is gonna is he going to receive? Who is he? What does he do? That is up to you. Everything is at your own risk. In public key cryptography, we have public key and private key, right? We call them together a key pair. Public key is known to everyone, and the private key is known to the owner only. If you may recall, when Alice wants to send something to Bob and she wants to encrypt the message so that Bob can open it alone, she is going to encrypt the plain text, okay, using Bob's public key and send this encrypted message, all right, scrambled message through the internet. And Bob is going to use his private key to decrypt this plain text. It works the other way around as well. Bob can use his private key to encrypt, and then Alice can use his public key to decrypt the message. But in blockchain, public key and private keys are used in managing your assets. When you want to receive any transaction, you will show your sender your public key, and the public key of both sides will be written on the journal on the chain. All right, so it's open. But when you want to transfer that asset to some other guys, you have like say 2 Bitcoin, you want to transfer one to your brother, you're gonna need your private key to execute the transaction. And without that private key, no matter how large your asset is in the chain, you will not be able to do anything with it. You can think of your public key as your prompt pay number. The difference is, if you lose your prompt pay number, if you change your phone number, if you forget your citizen ID, you can always go to the bank, okay, and rebind your new phone number with the existing bank account. The bank keeps the information for you. But in blockchain, if you forget your public key, if you lose your private key, you don't get to do anything anymore. What we have discussed so far is called distributed ledger technology, or DLT. Distributed ledger distribute the chain to everyone, and every transactions are open. We call this a public blockchain. All right, public blockchain has no restrictions on reading or submitting transactions to the chain. You can read any other information. It is completely trustless. So you don't trust anyone to keep the chain. The chain is open because you trust no one, and therefore everybody can have a copy. Everybody can cross-check. It relies on all nodes consensus. It is therefore slow and expensive, and it is public. What if you want to keep your transaction secret? You don't even want to show your public key. You could do that as well using what we call a private or consortium blockchain. This is a blockchain where you restrict who can access your data. You trust some entities to manage the blockchain for you. Other guys outside of this trusted circle, trusted entities, they cannot access to the chain. With this, okay, it is more efficient because only few guys maintain the chain, and every few guys gonna have the chance to compute new blocks. You don't have to compete, okay? Maybe you compete among like 5 or 10 people instead of 1,000 or millions people. Okay, so it is much faster, more efficient. and you can apply some control, some regulation, some rules that okay are going to be big companies that can access the chain. It has to be government agencies or somebody that are proven to access the chain. Private or consortium blockchain is good for efficiency, it's good for control. But with control, you just have to trust the guy that controls the chain or controls the rule. All right. And you can with this aspect, you can divide blockchain into two kind of policies. Permissionless blockchain is a blockchain that with no restrictions. Everybody can access, everybody can process. And Bitcoin is a good example of such permissionless blockchain. Another one is permission blockchain. It's a blockchain where all transaction processing or accessing has to be regulated. All right. It has to follow the rules. And the guys that can access this chain must be verified. Bitcoin, as we mentioned earlier, is a good example of public permissionless blockchain, right? But permission blockchain or consortium blockchain is not that bad. All right. Sometimes you're gonna need some control. For example, only banks are allowed to act to process or transactions or set okay or stock exchange or Thailand are is the only one that can process stock transactions in the country. All right. This system imposes censorship and control, but it also need no cryptocurrency because see, cryptocurrency was born because you need to get some fee, get some reward back for the processing. All right. When a lot of people try to compete to process, they should get something in return. But if you have just one guy or a few guys that can decide among themselves how can we process blocks, you don't need to compete anymore, and therefore you don't need any cryptocurrency anymore. It is just the you know processing and the contribution of processing or how much fee they're gonna get it based on contract only. The upcoming digital baht, I believe, is also implemented using permission blockchain as well. In this case, I'm not sure, but I would guess Bank of Thailand is the one that process the chain. But one thing I need to mention is that digital baht, it has no censorship. It means that any transaction that you do in digital baht chain will be recorded, and you need to verify your public key with your ID card, with your citizen ID. So they will know that this public key belongs to whom. You will have no privacy. So far, we have discussed that blockchain can be used to store transactional data. In effect, they are just accounting book that transfer that records the transaction between two individuals. Well, it is not long before somebody realized that we can do a lot more than that. We can store everything. We can store any kind of data, including logic. Have a look at this example. Smart contract is a computer program that is self-execute when a condition is met. For example, if the work is done, execute the transfer. If my lottery ticket is a winning number, then transfer winning fee to my account or to the owner. Or if A has enough fund, then transfer to B. All right. This logic is basically business logic written in a computer program, a computer script, and stored into a blockchain. Once this contract, okay, is written into the chain, nobody can change it because it is already embedded in a block in the chain. Okay, and we can configure the blockchain network such that the contract will always be executed when the condition is met. All right, so the code is executed automatically. You can't cheat people. When you agree that when something happened, when they have done their work, you need to pay, you will pay because the network forces you to make the transfer. The concept of smart contract has been introduced by Nick Szabo in 1998, even before Bitcoin was introduced. And based on that idea, All right, Vitalik Buterin developed Ethereum, the first blockchain system that supports smart contract. So you can embed any script into the chain, and the chain will execute the script when the condition is met. All right, the and then after smart contract concept was created, all hell break loose. Now you have decentralized finance. Now you have NFT or non-fungible token. You have play-to-earn gaming and so on. Because now you can have the evidence of owning something, or the logic of owning something, or logic of executing something built into the chain, and nobody can change that. Well, as long as the chain is honored. In conclusion, we discussed the concept of blockchain. We discussed how it works, okay, and we discussed how we incorporate the cryptographic method like hash function, public key crypto to make the blockchain work. And we also discussed a little bit on smart contract. But I want to in at the end of this class, I want you to keep a few things in mind. Blockchain is one of the most hyped topics in computer science right now. And I say hyped because everybody is talking about that. Everybody is trying to push blockchain forward and so on without knowing what it is. I mean, of course, there are a lot of people that know how it works, but there are also a lot more people that follow the hype without actually knowing what blockchain actually is. It seems to solve all the problems in the world, but I'm telling you, it is not. There are some problems that Bitcoin is good for, some problems it is not. As everything that is new, do not believe in all the hype. Blockchain is an awesome and practical invention, no doubt about that. You should know how it works, you should know how to make use of it, but you should not believe in everything everyone says, especially those who want your money. And if you want to trade cryptocurrency, well, please do so because you believe in long-term benefit, not just because you want to get rich out of it. And you can also mine cryptocurrency as well. But please be aware that you are hurting PC gaming community. Thanks a lot for joining me today. I don't have a channel yet, but you can click like and subscribe or anything in that nature down below. Bye.